All right. Let me begin. Hem. I will begin. Ahem. 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 I need a whistle. I'm bringing my whistle next time. Here we go. Dear Heavenly Father, we thank you for this day. I thank you for these students, even the ones that are not listening. Help them to enjoy this class today as much as we do, those of us who are listening. And we just pray that you be with us today. Help us to glorify you in what we do. And I just pray that you be with us today again, just to guide our steps, Lord. In your name I pray. Amen. All right. I obviously need a whistle to start class. I'll put that on my list of things to bring. Now, oh man, you're doing that to me. Ah, it's working. Here you go. 3715. There we go. All right, so just a couple of small comments. You know, I'm not quite sure how grades are syncing between WebAssign and Canvas. If they haven't synced yet, I wouldn't despair. I would say this: if you've done the problem in WebAssign, then you've done it. All right. If it transfers to Canvas, then great. If it hasn't yet, it will in the future when WebAssign works out the kinks. All right. It may be working, but I've heard other classes not working. I can only assume there's someone in here probably it doesn't work for. Anyway, just trying to tell you, Canvas is not the end-all be-all. Like, if you have grades in WebAssign, those are real grades. They will transfer eventually. All right. Any questions about that? Okay. So let me get into it here. So there are a lot of questions. So the other thing I was going to say is I did not have the forward to instructor button checked in the WebAssign messaging thing. So like about 20 of you have sent me messages through WebAssign I never saw. If I don't respond to a message you send me, that's because I didn't see it. All right. So, you know, I know some of you have come and talked to me about these same questions in person, so you followed up on it already, right? But as a general point of order, if you send me an email or a message or something and I don't respond to it within a day, I probably didn't see it. So you probably need to either, you know, come talk to me in person or send me the message again. Sometimes email eats messages here. Like, it's not uncommon for me to sit at the end of the semester at Christmas and then find an email that was sent back in September and is just now reaching my inbox in December. That happens here on occasion, not always, but sometimes. And so not just this class, but all your classes, if you have a professor you're communicating with and they don't communicate back to you, I wouldn't assume that they're just not, I wouldn't assume they're ignoring you. There's a good chance that they never got your message, you know? So like if you have a message that's important, follow up on it here. Don't just let it sit there. Now there are, of course, also people who just don't answer email. Like those people also exist. I'm not one of those people. Okay, so anyway, any questions about that? Okay. You know, office hours, all that good stuff. But one of the things that showed through in the messages that I was looking at through WebAssign was that a lot of you needed a couple more examples like this. So I thought I'd take some of our class time today to review this concept. Most of you have already got this problem right, but let's just take a few minutes to review it together, make sure we're all on the same page for like when the quiz and test comes, okay? So here's one. Consider the set defined below using set builder notation. Here we have x squared minus 3x. Such that x is an integer, and it's between minus 2 and 3, where 3 is included, but 2 is excluded. Minus 2 is excluded. So what is I? it's 0 and then plus or minus whole numbers, right? So if you look at that, if I have minus 2 less than x less than or equal to 3, aw, man. Oh, rats. You ever edit something and not edit everywhere you wanted to? Come on. It won't let me edit. Well, no. Just a second here. I'm trying to get out of the... Huh. Well, it won't let me edit it for some reason. I don't know why. I must be in some kind of presentation mode or something. All right, well, I'll have to do it after class. I'm sorry, guys. So what I'm trying to get at here is this I changed to a 2. All right, but I forgot to change it up here. I only changed it here. All right, so my bad. I wanted to change that to a 2 to make the example easier to follow. Anyway, so take that 3, change it to a 2. If we do that, then the integers which are between 2 and minus 2 and 2 included are minus 1, 0, 1, and 2. And then, so then we just plug those numbers, right? X equals minus 1, 0, 1, and 2 into the formula x squared minus 3x. Now, how do you do that? Well, you plug it in, right? So I plug the numbers into the formula like so, calculate, and I get 4, 0, minus 2, and minus 2. Remember, we're dealing with sets, so we do what? We only keep one copy of minus 2, right? So the answer would be 4, 0, minus 2. So, any questions? I don't think I did enough of the previous lecture, so you guys were kind of lost on the homework problem that was like this, yeah? For those of you in pictures, remember that 3 is supposed to be a 2, okay? I will hopefully post this PowerPoint after class. I fixed that 3 to a 2, yeah. All right, example 2. Consider s equals to x cubed plus 1, where x is a natural number and 3 is less than x is less than 10. All right, so what natural numbers are between 3 and 10? Well, 4, 5, 6, 7, 8, and 9 are between 3 and 10, right? And so what I do is I take my formula x cubed plus 1 and I plug in 4, 5, 6, 7, 8, and 9, right? And when you do that, you get these formulas. And when you plug them in your calculator, you get 65, 126, 217, 344, 513, and 730. So there's that. I do intend the test to be numbers small enough that you can probably do it without a calculator. The exception to that is like powers of 2. I do want to have powers of 2 up to at least the 10th power on your formula sheet, because we've had some like pizza problem and the sandwich problems. I'm sure you know powers of 2 up to like, I don't know, 12 or something like that. If in doubt about what the 2 is test, you could ask me, I would tell you, right? But all right, you do need a calculator for the middle third of this course, though I should mention that. You will need a calculator for the middle third, because that's financial math, and there's formulas there that are ugly that require a calculator. Example 3. This one's a little different. I said consider the set S to be L1 and L2, where L is a letter in cat, and L2 is a letter in dog. All right? So logically, we have L1 is an element of the set containing C, A, and T, whereas L1 is an element of the set containing C and T, whereas L2 is an element of the set containing the letters D, O, and G? Football? American football, right? Okay, yeah. Did I ever tell you guys the story about the guy watching soccer in my class? No? So I taught physics, and I had this guy, and I knew he was smart. Like, I had him in college algebra before I had him in physics. He made like 100% on everything. I mean, he was not a dummy. But every day after physics, he'd come to my office hours and like basically ask me to re-lecture the whole lecture to him. And I was like, what are you doing? Like, and I noticed that he's on his phone a lot. And I said, I think you're spending too much time texting in class. I shouldn't need to reteach the lecture to you. You should be able to get it the first time in class. I think you're getting distracted by your phone. And he said, oh, no, sir, I am not texting. I'm watching soccer. I'm like, that is so much worse. Although I would say watching soccer is worse than watching football, just as an American. Sorry, just how I was raised. The rest of the world, of course, would say soccer is football. But anyway, so if we're taking possible two-letter words assembled from the letters C, A, T, and D, O, G, you have to take one from here and one from there. What do you got? And they have to be in this order, right? They have to be L1, then L2. Then your combinations are either CD, CO, CG, AG, AO, AG, TD, TO, or TG. You got these 9 possibilities. As I said, most of them are not scoring in Scrabble, with the exception of what? I think TO is a Scrabble word, right? Any of the other ones here Scrabble words? I'm a little rusty on my Scrabble. I've forgotten my made-up Scrabble words. CD is an abbreviation. Can you put abbreviations down in Scrabble? I think it depends on who you're playing with. It's kind of like when you're playing Uno. You can put down 1 card, right? Or you can put down 4. Depending on how much your opponents are paying attention. See, they say Uno is not a game of skill, it's a game of chance. That's only true if you don't cheat. So, teach my children to be wary of cheaters. Anyway, you had a question?
Oh yeah, so that's called the solution of the set. Is that the solution?
Yeah, so I wanted to, the question was to write S in roster notation. Here it is. So roster notation, roster notation is when we just list all the elements of the set. And so that's it. That's this. The solution is literally this piece right here. Like that's the answer. So the sentence before it is the work which leads to it, All right, let me move on here. In class exercise. All right, so soon I will top hat. So you guys work this out, and then I will create a top hat quiz to assess your choice. So write this out, work it out. I'll give you about a minute to do it. Sorry. I'll get back to it. Give me a second here. Once you think you have your answer, raise your hand. All right, you can put them down. I'll test again here in a couple seconds. I think we're missing about 30% of you. Wait a minute, how many people here are not going to get an answer and don't care? No one's so foolish as to raise their hand. It's good. You're like, I think he's not petty, but I can't be sure. Good call. What's that? All right, I'm going to go make the quiz, then I'll come back to this in a second. Ah, come on, Top Hat. Behave. Where'd you go? All right, you guys should see it. I'm going to put the PowerPoint back up here. Oops. So that's the A, the B, the C, and the D. Seventy of 99 have done it. So far, 44 of you have gotten it correct. Let's see here. 75, 76. How many people are in here? Rats. All right, hold on a second here. Uh-oh. It's still there? Is the quiz still there? Is it gone? Is it there? All right. Anybody still trying to do the quiz? Everybody done? All right. All right, well, I'm going to get back to back to the lecture then. Let's talk about the answer here. It was what? It was D, right? Because you have 2 less than or equal to x less than or equal to 5, which gives you x equals to 2, 3, or 4. And you plug that in, you get 6 plus 1 is 7, 9 plus 1 is 10, and 12 plus 1 is 13. So the answer was, in fact, D. So if you got that, great. If you didn't, oh well. Okay, so moving on. The rest of the class, I need to talk to you guys about logic. All right, so now, I mean, logic definitely predates Boole. What Boole did was to formalize ideas of logic and argumentation, which are pretty old. I mean, at least going back to the Greeks. I mean, honestly, as long as there have been humans, there's been logic, you know? Maybe we don't have, like, written record of it or something, but it's pretty much, I can't imagine a society without logic. Although sometimes they watch the news. But anyway, so that's not true. I don't really watch the news. But anyway, so George Boole lived 1815 to 1864. Well, how old was that? If it was 65, how long would it have been? It would have been 50, right? So I apparently lived to be 49. Anybody know how he died? Murder? That's a fun answer. But no. So apparently he's like walking from his house to the place where he was, lecturing, and it was raining, and he's wearing like a thick coat or something, and it got wet, and then rather than like not lecture in the wet coat, he lectured in the wet coat, and then came down with pneumonia. And then, being a 19th century person, his wife thought, well, he got sick from getting wet, so we should cure him with wet blankets. So then they wrapped him in wet blankets, and he got worse, and he died. At least this is what Wikipedia says, and yeah, Wikipedia is usually right about these sorts of things. So anyway, kind of a sad way to die, I suppose. But he did a lot. He did quite a bit in his life. He had 2 major monographs, one of which is probably most related to what we're talking about today, namely Symbolic Logic. Its title is this: An Investigation of the Laws of Thought, which are founded on the mathematical theories of logic and probabilities. That's a long title, So anyway, in this, basically, he describes symbolic logic and so forth. And now some people said that he was trying to correct errors of Aristotle, but I think what I was reading suggests that in fact he had a positive view of Aristotle and was really just trying to formalize the logic which the Greeks made popular in, Western civilization, I suppose. Also, interesting bit of trivia, he married the niece of the explorer for whom Mount Everest is named. I'm sure Mount Everest has like a different name amongst the indigenous people who live there, right? But it's probably not called Mount Everest, is it? But anyway, Boole and her name was Mary Everest were married in 1855. So between 1855 and when he died in 1864, they had 5 daughters. So I guess that makes his death a little bit more sad. He had a lot of young daughters when he died. All right, so moving on. Definition. What is a statement? All right, a statement is a declarative sentence that is either true or false, but not both true and false. All right, so here's a laundry list, some silly, some not, of things that are either statements or not statements, or it's debatable. All right, so like, here's something that's pretty much not a statement. Rain on a sunny day is nice. This is a matter of opinion. It's not really true or false. It kind of depends on what? Who you are, right? Now, if you change this sentence to something like, Matthew says, rain on a sunny day is nice, then it becomes a statement, right? But there's an ambiguity to the sentence which would make me say that's not a statement, number one. What is your favorite movie? Again, not a statement because this is a question. It's not a declarative sentence, right? So it's not a statement. All right. There have been more VIIRS reports in the last 2 years than in previous decades of reporting. That is a statement, which happens to be true. Do you guys know what the VIIRS report is? Nobody? This is the vaccine adverse event report system. In the past 2 years, there have been more reports to that than its previous 30 years of existence. Fun fact. Statement 4, COVID vaccines are safe. I would say in view of 3, this is debatable. But this is not a statement. I would say, how do we define safe, right? So you could debate. Now, if you had given a careful definition of what safe means, perhaps this number 4 would be a statement. But as it stands, I'd say no, it's not a statement. Shutdown policies hurt the global economy. I think this is a statement. It could either be true or false, right? Florida is a country in Asia. This is a statement because it's either true or false. Now, this, of course, is false, right? As far as I know, is there some Asian country that recently renamed itself Florida? I mean, every so often, countries change their names, right? Like there used to be a country called the Ivory Coast. One of my mom's friend was a missionary there. I don't think it's called the Ivory Coast anymore. I forget what it's called. Anybody know? The what? What he said. Okay, so. Oh, but it's just Ivory Coast in French or something, or no? All right, well. Let's see here. If you have questions about geography and so forth, you can all go ask Professor Bradshaw. He's the expert. All right. So, let's see here. A study was done which showed cloth masks provide no reduction in infection from COVID, and a marginal reduction from the use of surgical masks. Actually, 10% reduce in infection for wearing surgical masks. This is a statement. In fact, there was such a study done. It's been ignored. Trump was a Navy SEAL. This is a statement. Obviously false, right? And then 9, all generalizations are false. What do you guys think? Statement, not a statement? Why or not? Is it true? If it's true, what's the problem? It's a generalization, yeah. So it's self-defeating. If it's false, then what? It's still a generalization, so it would make itself false again. So this is an undecidable statement, all right? Well, it's not a statement is my point. Unfortunately, I just used statement again in my sentence. I didn't mean to. This is a sentence which is not a statement in the technical sense we're talking about right here. I would point out that this is also the looming problem of postmodernism. Postmodernism rejects all meta-narratives, and yet itself is a meta-narrative. Well, anyway, I'll go on. All right, this one's less political. Again, definition of statement is a declarative sentence which is either true or false, but can't be both true and false. All right, so here's some more. Number 1, I am going on a walk today. This is a statement, right? I think anyone who takes classes in DeMoss can say this is true, right? You've gone on a walk. Logic. So there are two main operations in logic. There is conjunction and there is disjunction. I will tell you this, in mathematics we almost never call it conjunction and disjunction. We almost always call this and or. All right, or you could say logical and logical or. And I think if you talk to, for example, like electrical engineers who study logic for like digital logic design, they'll agree with me that it should be and or, not conjunction and disjunction. I think conjunction and disjunction, that kind of language is probably more popular with like, oh, I don't know, lawyers, if I had to guess. So anyway, the truth value of a simple statement, it's either true or false, all right? The truth value of a compound statement depends on the truth values of its simple statements and its connectives. So the connectives in these tables are the and or the or, all right? And you can make a truth table. That's a table which shows the truth value of a compound statement for all possible truth values of its simple statements. So like we're talking about mathematical and, all right? Or conjunction as it's known. See, you either have true and true, true and false, false and true, or false and false. Those are your four cases, all right? Same thing for over here. You either have true and true, true and false, false and true, or false and false. Those are the four cases when we're talking about or. Now the way these are defined is and is only true if both P and Q are true. All right? So for example, you need proper attire and a reservation to eat at Overpriced Steakhouse. All right? I just named it Overpriced Steakhouse. You guys can give me a more specific name if you like. I don't know. You guys got exciting people you're trying to woo, take them to the Overpriced Steakhouse, impress them with your ability to waste money on them? No? This is a bad path, by the way. If it works, you're going to be with them for decades. You need to set the bar much lower. Much lower. You go easy on the woo to start with. Save more woo for later. You don't have that much money. I don't know who you are. Maybe you have that much money. I don't know. But, okay. Disjunction or logical or over here, 3 less than or equal to 5 is true. Why? Because we could think of it as the compound statement P or Q, where P is the statement 3 less than 5, all right, and Q is the statement 3 equals to 5. Now 3 equals to 5 is what? Is 3 equals to 5 true? No, that's false, right? So Q here is false, but is 3 less than 5? Sure is, right? So P is true, and Q is false, and so I've got true, false. In this case right here, for my example, true, false for logical disjunction is true, right? So the way OR works is if either one or the other of the statements or both are true, the OR statement collectively is true, all right? Any questions? There, we could do another truth table here. Let me try one that's a little bit more complicated. I'm going to write it up on the board here for you guys. Now we'll do more truth tables next time, but I wanted to do one this time, and in the so here we'll have P, we'll have Q, and we'll have R. All right, and then over here I'm going to have P and Q. All right. And then over here, I'm going to have P and Q or R. And then finally, I'm going to have not P and Q or are. Now, I'm doing, so your book, if you read it, it has 2 examples which it does in the style I'm about to do, and then like everything else it does in a different style. So there's 2 different styles of truth table your textbook has. And I'm going to do it in the style the first 2 examples are done, okay? 'Cause I think this is actually the easiest one to understand. I mean, the way your textbook does things after the first 2 examples, I'm not as fond of. I mean, I'm going to show it to you next lecture, all right? But, all right, so here we go. There are true, true, true. We could have true, true. Let's see, I'm trying to follow the same pattern over here. True, true, false. True, false, true. True, false, false. And then the same pattern again, but with false, false, false in the first column. Let me put some dividers in here. Can you guys see it? I will not erase this, and I'll leave this up, so you know, if you need to look at it after class, you can. All right. So the way this works is you just fill in the columns to the right on the basis of the columns to the left, all right? There are 8 choices when you have 3 simple statements. So the simple statements here are symbolically P, Q, and R. Okay? So P and Q. P and Q. What do we have there? P and Q. True and true. P and Q is true. P and Q. True. P and, oh, there's got a false. True, false, that's false. True, false. If you have either one of them's false when you do and, it's false. Down here we have false, true, which is false. False, true, which is false. False and false is false. False and false is false. All right, so there you go. That's P and Q in the, I guess technically it's the 4th column. I really should put some dividers in here just so I can talk about it properly. So the 4th column here. How about the 5th column? Now, I'm going to do some circling to try to explain the logic here. What we're looking at to figure out the 5th column is we're looking at the one we just did, right? So we got to look at this one and also this one. Okay, so or true or is true or true true? Yeah, that's true. If we have false and true, we're using or. What's the result? True. Yeah. True, false, true. False, false. That's the only way to get false from or is when you have false and false put together. When we look at the truth table over here, like for disjunction, the only false case is when we have both of them are false, right? In contrast, the only one that's true for the and is when both of them are true. Okay, so here we go. True, false, true, and finally false. Now, I haven't defined this yet, but what's negation? Yeah, we true becomes false, false becomes true, all right? So we just turn the logic over. So that's very simple. To negate, and I missed a bracket here. I meant to put this bracket followed by that one, okay? So all I do is I make true, false, and false, true to get the final column. Let's see here. So I got false, 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 true, false, true, false, true. And so one of the things we could use truth tables to investigate is whether or not two logical statements are equivalent. When would two logical statements be equivalent? What would that mean? That would mean they're both based on like the same simple statements, all right? And that if the simple statements match up, then the logical truth of the logic matches up. So like you could make a truth table for two different logical sentences, and if they have the same true-false values for the same inputs, then they're equivalent statements. All right? We'll look at one of those examples most likely Thursday, all right? I'm going to go on here. I just wanted to kind of expand on this truth table slide because I really don't have much to say about truth tables today except for that. All right, so let's review here. What is a simple statement versus what is a compound statement? A simple statement is a statement that conveys a single idea, right? A compound statement is a statement that conveys two or more ideas. I think if you go back and look at my political slide, you'll see that some of those were compound statements, weren't they? I didn't say one thing, I said a few different things strung together, right? Anyway, connecting simple statements with words and phrases such as and, or, if, then, or if and only if, this is how we create a compound statement. All right. He has an example here. I will attend the meeting or I will go to school, right? That's a compound statement. What are the simple statements that make up this compound statement? I will attend the meeting, right? That's one simple statement. And I will go to school, that's a second simple statement, right? They're joined together by this word or here. So you could look at this as a disjunction of the first part of the sentence with the second part of the sentence, right? I'll give you some more examples here. So this is, well, my examples are the slide after this, technically, but these are simple examples, but I have some more to show you. Let's see here. Let me get back away from the slide for a bit. So, oh, forgot my glasses. So here are the, we've talked a fair amount about and or already, all right? Or conjunction and disjunction. We'll talk more about the conditional and the biconditional next time, all right? Those are, we'll talk a little bit about those today, but not quite. I mean, like I'm going to show you the truth tables for the conditional and the biconditional next time. Negation, we talked a little bit about that already. So here are the words that you typically see when this logic is being used. Not for negation, and for conjunction, or for disjunction, if then for the conditional, if and only if for the biconditional. All right. And here's some examples. The negation, so here's P. P is the statement, a dog is tired. Q is the statement, the cat is dead. Okay. I like this slide. I'm sorry, cat people? Yeah, like I'm not going to be involved in the silliness of this lecture. I'm above it. I will not, you cannot draw me into it. I will not be seen here, engaged in this. Fair enough. Fine. So the negation of the dog is tired is the dog is not tired. All right. The negation of the cat is dead is the cat is not dead. The conjunction of P and Q is the dog is tired and the cat is dead. The disjunction of P and Q would be the dog is tired or the cat is dead. All right. Symbolically, this is not P, this is not Q, this is P and Q, this is P or Q. I hope you can start to see there's something really beautiful in this way of thinking of collapsing whole sentences to these just simple expressions, right? because if you understand the laws of logic, you can sort through very complicated logical paragraphs by just a few different letters. Yeah. And anyway, moving on here. All right. So here, I'm not going to get top hat out because it is a distraction. But I do want you to try to work these out for yourself, okay? So here we go. Consider the following statements. P, today is Friday. Q, it is raining. R, I am going to a movie. And S, I am not going to the basketball game. All right? So try it for yourself. What symbolically would this part A be? What do you guys think? Today is Friday and it's raining. What would that be? I heard a P and Q. Do you guys? I think I agree with that. Right? How about B? It's not raining, and I am not. Excuse me. It's not raining, and I am going to a movie. Yeah, negation. So not Q and what was it? R. Not Q and R. We think. All right. I've got the answers on the next slide, so we'll see. All right. So you guys have to keep track of our answers. Hopefully we got them right. I am going to a basketball game, or I am going to a movie. Ooh, this is a little bit tricky. What? See, S is what? I am not going to a basketball game, right? So this would be what? This would be not S, or R, right? So not S or R, I believe. And then this one, if it is raining, then I'm going to the basketball. This is a implication, all right? Or a conditional. So it would be Q implies S. So here's the answers here. So the solution, like we said, P and Q, not Q and R. Did I say or R there?
Yeah.
I should have said and. Did I change the wording? No, I'm sorry. If I said or there, I obviously shouldn't have, right? Because this is definitely, it's plain as day right here, right? And. All right. So not S or R for C, right? And then this right here, this arrow, is implication or conditional, right? If Q, then R. Symbolically would be that one. Next example. Consider the following statements. The game will be played in Tuscaloosa. The game will be shown on CBS. TBS, that'd be different. The game will not be shown on ESPN. The Crimson Tide are favored to win. All right. So this is, I lived in Alabama the last 2 years. These are inescapable discussions. I'd say it's a religion, but I think that falls short. Like people are not religious enough in order to, well, maybe here it's different, but let's see here. So here's the answers. So Q and P, what would that mean? That would mean that the game will be shown on CBS, right? That's P, that's Q. And played in Tuscaloosa. So that's Q and P. There we go, that's A. So I'm converting from the symbolic statement to the corresponding English sentence. All right? Not R and S. That would be the game will be shown on ESPN, right? That's the negation of it will not be shown on ESPN. And the Crimson Tide are favored to win. Shocking. All right, so there you go. That would be not R and S. This one is the biconditional, right? Biconditional. So here it is. S is the Crimson Tide are favored to win if and only if the game is not played in Tuscaloosa. That's not P. So of course C is absurd. I think they pretty much always win if it's played in Tuscaloosa. But anyway. Go Flames. All right, let's go on. Okay, so, I mean, I love the Flames exactly as much as I love the Crimson Tide. I will tell you that. So, those are empty statements. But anyway, let's see here. So it's a compound statement written in symbolic form. Then parentheses are used to indicate which symbol. So basically, put a slide parentheses matter. Right? It matters which you combine first and last. Okay, so like this one means that Q and the not R, they're grouped together by disjunction, right? Q or not R. Here, P and Q are joined together first. And then here, you've got to do P and not Q implies R or S. So, like, you have to work within the parentheses first and then out. So here's a short description, like as it says, Q and not R are grouped together. P and Q are grouped together here. P and not Q are grouped together. And so R and S are grouped together under the or right there. All right. Under disjunction. Moving along here. I should also mention that a compound statement written in English sentence, we often use a comma to indicate which simple statements are grouped together, right? So statements on the same side of a comma are grouped together. For example, if we have P, comma, and Q or not R, that means that the Q and the not R are grouped together, all right? Now this one, we have P and Q grouped together, and then the R on its lonesome, right? Now here, P and not Q are grouped together, as are R and S, right? So in fact, that refers exactly to the previous slide, right? So like these sentences, you got to go back, you got to use your memory here, but these sentences right here were symbolically covered right here, all right? So when you're looking at this, the next slide refers to the last one symbolically. You could line these up together. Example 8. Let P, Q, and R represent the following. P, you are emperor. Q, you complete the training. R, you will park on level 3. You know you got here early if you park on level 3, right? Or you're lucky. So, question A, try to change this English sentence. If you do not complete the training, then you will not get to be emperor and you will not on level 3. Put that into symbolic form, all right? And then B, we're going to try to write P or not Q and R, parentheses as written here, as an English sentence. And then we'll try to write that as an English sentence, all right? Okay, so let me look at the answers here. So, all right, training was Q, right? Training was Q. So if you do not complete the training, that's not Q. This is an if-then statement, so that's a conditional, right? So I do the arrow. Then you will not get to be emperor. That is not P. Wait a minute, what? Oh yeah, not P. Sorry, my eyes played tricked on me. I saw a Q there. And you will park on level 3. That's R, so and R. So did you guys follow part A? Did you see what's going on here? It's just a way of symbolically representing sentences. Okay. Part B, write P or not Q and R as an English sentence. So here it goes. You are emperor, or, comma, or you did not complete the training and you parked on level 3. The next one, write P or parentheses, not Q and R, close parentheses. Yeah. So here we go. You are emperor, or you did not both complete the training and park on level 3. So I use both and here just to make sure I paired the Q and the R. I mean, there's